So I'm Jalisha, Assistant Professor, Department of Mathematics, St. Joseph's College of Arts and Science for Women Hosur. Today we are going to see the topic relations in discrete mathematics. Relations. The elements of a set may be related to one another. If there exists a relation between any two elements in a set, then that set is said to have the relation. For example, if we are considering the natural number set, we can define the less than relation among the elements of natural number set. For example, natural number means no point values will be there, only the round off number from 1, 2, 3, and it goes on. Now, if we are selecting any two elements, 1 and 3, we can say 1 is less than 3, 2 and 8. We can say one number will always be less than the other in the natural number set. So, for inside the natural number, we can define the relation less than symbol. And even we can define less than or equal to, because the same numbers, if we are comparing, means equal to will also exist. So less than or equal to relation will also exist in the natural number set. Then the next condition for a relation is only within the same set a relation is exist, means it is not the case. It can exist between any two different sets. So the elements of one set may also be related to the elements of another set. This is called as the relation property. Next is about binary relation. Binary means it is between the relation between the two sets. So two sets means one element from the first and the other element from the second set. So those relation can be denoted in the form ordered pair. So here I am showing A comma B. So here A comes from the first set A and B comes from the second set B. If a relation exists between A and B, means that can be expressed in the ordered pair form. That is, inside a open bracket we can combine those two elements. If such relations element exist between all the elements of A and B, means then the two sets are said to have the Cartesian product value. Okay, so the Cartesian product of those two set is denoted in the form A cross B. So binary relation means the relation between any two different set is having a relation exists between the first one to the other, and if the relation exists, it is denoted as A related to B, A or B. Here I am showing A, small a, capital R, small b, means A is related to B. If the relation does not exist, means it is denoted as A does not related to B, and it is taken from the order relation A comma B belongs to X. Here the empty set, which is also a subset of X, and here X is called as the void relation in X. If suppose a relation exists between X2 itself, means it is called as the void. So let's see here. If suppose X and Y be any two sets, then the subset of the Cartesian product X cross Y defines a relation C. And for such relation C, D of C is the domain, R of C is the range. Then we can say C is the relation exist from, which is the D of C set X, and which is the R of C set Y. So the relation exists from X to Y. If in a case X and Y are equal, means then we can say C is the relation from X to X itself. In such case, C is called as the relation in only X. And that type of relation is called as universal relation. It is also called as the void relation in X. Next, we are going to see about the equivalence relation. Equivalence relation means it is again a relation between any two elements. It can happen from two different set or between a same set, but it should satisfy the three properties for equivalence relation. The first one is reflexive. So between same elements a relation exists, means that is called as reflexive. So in the previous slide we have explained a relation A related to B, and the relation is A is the father of B. Whether reflexive exists there, A is the father of B, means then B should be the child of A. This is the only case. But we can't say A is the father of A itself. It is not possible. So in such problem, reflexive will not exist. But in number systems, natural number, if the relation is less than or equal to is defined, means 2 is equal to 2 is possible, 2 is less than 3 is also possible. So in such case, relations reflexive is also possible. So reflexive means relation between the same elements. Next is about symmetric. So generally in the smaller level of education, we all know what is mean by symmetric. A circle is divided into two equal half, means that is called as the symmetric part. Both upper part and the lower part will be same but in the reverse direction. So in the upper part, if I am defining the relation as A related to B, what about the below part? It will be the same format, but it can be reversed. So B is related to A. Both are same in the reverse order. That's it. So this type of relation is called as symmetric. If A is related to B and if it's symmetric, means it directly implies that B is also related to A. That is the second property, symmetric property. A related to B implies B related to A. Next is transitive. Transitive means if two relations exist, A related to B and B related to C, then using the connector or the transmitter B, we can form a new relation that A is related to C directly through B. So this implies what you'll get, the final answer is combining those two, we'll get A is related to C. This type of relation is called as transitive. So it is given here A related to B and B related to C is combined, means you'll get A related to C, where all the three elements are from A. This type is called as transitive relation. If all these three type of relations exist in a set, means then that set is having the equivalence relation property. Now let's go with the example. The relation equality of numbers on a set of real numbers is one example. The other example, the relation being parallel on a set of lines in a plane. So let's have a plane. Plane means two dimension. So we are considering two dimension. Set of lines. Here one line, this, again one line, this line. So here on seeing these lines, what about the shapes we are getting here? Triangles. See the tick which I am giving, all are triangles. So what the examples question is saying is the relation being parallel on a set of lines in a plane with or in T. So those lines are related in the form of triangle. So it is given here as T, capital T. And the relation is defined as if two elements in the triangle A comma B, if I am considering this point and this point, so we can say these two are related. What about these two? These two elements are from the triangle 1. The first triangle, in that 2 points we have selected. This is the first point and this is the second point. If those two elements are related, means the elements will be from capital T, then the property is based on if it is going to be related, means those 2 points should be in the similar form. Those two should be from the similar triangles. We always know that if for a same triangle, if I am considering one triangle like this, if we are checking this triangle is similar to itself, means yes. If we are showing the mirror to it, it will be look as it is. So the triangle is always similar to itself. The relation exists between the element and itself is called as the reflexive relation. So for this triangle, the reflexive property is automatically true. Next, we need to say the Second property, symmetric. Symmetric means what is the definition? A related to B implies B related to A is the thing. So if first triangle is similar to second means automatically if first triangle is similar to the second triangle means automatically the second will also be similar to first one. So symmetric is also obviously true for similar triangles. What is the third one? Transitive. So A is similar to B. So triangle A, this is the triangle A and this is triangle B, and next we are going to draw the third triangle. This is triangle C. If A is related to B, similar. Related means here what is the property? Similar. And B is similar to C, then we can say A is similar to C also. This will automatically happen. So all the three properties of the equivalence relation is obvious for the similar triangle properties. Hence, if we are defining the relation between 2 points between the similar triangles, then it is called as an equivalence relation. This can be verified for the numerical valued set also. Next is about the converse relation. So if we are defining a relation from x to y, then the converse relation is from y to x. It is also called as an inverse relation. So the relation x r to y is conversely represented as y r x. And here an example is given. First R is for the normal relation. It is given as 1, 2, 3, 4, 2, 2. Now the converse of it means the first element goes to second place and second comes to first. That's the only change. So 1, 2 is denoted here as 2, 1 in the converse relation. 3, 4 into 4, 3, 2, 2 as 2, 2. So this is called as converse relation. So here are some practice questions to determine the domain and the range set, and also a numerical set value is given with the divisible property of 3, and here while we are subtracting the considered elements, that answer should be divisible by 3. Then we can say the relation between x and y will happen. This is the defined relation for these elements 1, 2, 3, 4, 5, 6, 7. We need to prove whether it is an equivalence relation or not. Practice these two questions. In the next video, we are going to see about the functions and its types. Thank you all.